Dear students, in this class let us discuss about the characteristic of a Fredholm solution, Fredholm integral equation. So consider a result. We know that what is a characteristic of values, what a Fredholm integral equation. Now let us discuss about the property or the properties of this characteristic equation or characteristic values. So consider a result. The characteristic number of a Fredholm solution with a real symmetric kernel are always real. The real symmetric kernel, when the kernel is real symmetric, then its characteristic values are also real. That's our requirement. So what is a symmetric kernel? If k x theta be a symmetric kernel, k x theta be a given kernel, then it is symmetric if k x theta equals k theta x. So this kernel k is said to be a symmetric kernel if it satisfies this condition. So consider a characteristic equation. Consider this y of x equals lambda integral a to b k x theta, where k x theta be a symmetric kernel, k x theta y theta d theta. Okay. Consider this Fredholm integral equation. Y of x equals lambda integral a to b k x theta y theta d theta. Here it is given this k x theta is symmetric. K x theta is symmetric such that here k x theta is symmetric, means k x theta equals k theta x. Okay. Then we have to show that this characteristic values are strictly reals. So for showing the characteristic values are reals, we just assume that let lambda n be the characteristic value. Suppose it is not real, means it is suppose alpha plus I beta be the characteristic value, where alpha and beta are reals. Okay, alpha plus I beta, that lambda n equals alpha plus I beta be the characteristic value or the eigenvalue of the given Fredholm integral equation. So, since alpha plus I beta is a characteristic value, surely we can say that alpha minus I beta is also a characteristic value. Since alpha plus I beta is a characteristic value, then alpha minus I beta is also characteristic value. Then here alpha minus I beta equals lambda n bar. Alpha minus I beta equals lambda n bar. Lambda n equals alpha plus I beta. Its complex conjugate is lambda n bar. So it is alpha minus I beta. So lambda n be the characteristic value. Then its corresponding characteristic function is theta ynx. If lambda n be the characteristic value of the given Fredholm integral equation, then the corresponding characteristic function is theta ynx. So, in the light of that argument, we can say that whenever lambda n bar, that is alpha minus I beta, be the characteristic value, then the corresponding characteristic function is theta ynx bar. Okay. Therefore, this y here y of x equals this one. Therefore, what is ynx? Ynx equals lambda. Lambda means it is alpha plus I beta into, or lambda n into, that is alpha plus I beta, integral a to b k x theta yn theta d theta. Now give us equation 1. Okay. So what is yn bar x? Yn bar x equals, it is lambda n bar, that is lambda n bar, that is alpha minus I beta, into integral a to b k x theta yn bar theta d theta. Mark it as equation 2. Okay. Then consider, what about now? Therefore, you can multiply this throughout by ynx and integrating from a to. So what you get? Therefore, integral a to b, it is ynx yn bar x dx equals alpha minus I beta, that is multiplied equation 2 with the ynx, and it is integrated from where to where? A to b. then integrate a to b yn x yn bar x dx equals alpha minus I beta into, it is integral a to b yn x into integral a to b k x theta yn kx theta into yn bar theta d theta dx. Agreed. So that means integral a to b yn x yn bar x dx equals, it is alpha minus I beta into integral a to b, it is yn bar theta, integral a to b yn bar theta into, it is integral a to b yn x k x theta dx all into d theta. Okay, so listen here, we have integral a to b yn x yn bar x dx is alpha minus I beta into integral a to b yn bar theta into integral a to b yn x kx theta dx all into d theta. Okay, now listen, what is actually this yn x? From here, this equation 1 gives, here yn x by alpha plus I beta, equation 1 gives yn x by alpha plus I beta equals integral a to b k x theta y theta d theta. Okay, therefore what is yn theta? So from here we know that yn theta by alpha plus I beta equals, it is integral a to b k, replace x and theta are interchanges. You can interchanges x and theta. So what you get? It is yn theta by alpha plus I beta equals k theta x y of x dx. Okay, but we know that k theta x is same as kx theta. Why? Because the given kernel is symmetric. So it is yn theta by alpha plus I beta is integral a to b k theta x y of x dx. Listen here, there is a term involving this equation, equation 3, integral a to b yn x, or yes, integral a to b yn x kx theta dx can be replaced by yn theta by alpha plus I beta. So this can be rewritten as integral a to b yn x yn bar x dx equals, it is alpha minus I beta into, what remains, it is alpha minus I beta into, yes, it is integral a to b yn bar theta into, what remains it is yn theta by alpha plus I beta d theta. Okay, this equation is converted into in this way, that is integral a to b yn x yn bar x dx is alpha minus I beta into integral a to b yn bar theta into, this is nothing but yn theta by alpha plus I beta into d theta. Agree? Therefore, that means, so this implies, on cross multiplication, it is alpha plus I beta into integral a to b yn x yn bar x dx equals, come to the right side, it is alpha minus I beta into integral a to b, it is yn bar theta into yn, yes, it is yn bar theta into yn theta d theta. Okay, that means it is alpha plus, sorry, this is a common term, so it is alpha plus I beta minus of alpha minus I beta into, bring all the terms to the left side, but I get alpha plus I beta into alpha minus I beta into alpha plus I beta minus alpha minus I beta into, what remains here, integral a to b, it is yn x into yn bar x dx equals 0. Replace, you can replace, this is a, what about this one, this is a definite integral, so it is strictly independent of the variables. Therefore, it is the right side is nothing but alpha minus I beta into integral a to b yn bar x yn x dx also. So if you put all the terms on the right side to left, we have alpha plus I beta minus alpha minus I beta into integral a to b yn bar x yn bar x into yn x dx equals 0. Okay. So that means alpha and alpha cancelling each other. So it is 2I beta into integral a to b. What is yn x into yn bar x? So listen, if lambda n, what is lambda n? Lambda n equals alpha plus I beta, then the corresponding yn x. What is the corresponding yn x? It is f of x plus I into g of x, or fn x plus I into g n x, whatever may be. Okay, fn x plus I into g n x. If lambda n is alpha plus I beta, then corresponding yn x is fn x plus I g n x. So what about the lambda yn bar x? Yn bar x equals, it is fn x minus I into g n x. So what about that product? Yn x into yn bar x. This implies yn x into yn bar x equals, it is the product is nothing but fn square plus gn square. Okay. Therefore, it is 2I beta into integral a to b. It is fn square plus gn square dx equals 0. Surely the term involved in this is fn square plus gn square. So surely the term or the integrand is non-zero, or the terms integral a to b fn square plus g square dx is non-zero. That means 2I beta equals 0. That happens only when beta equals 0. Beta equals 0 means we assume that lambda n equals alpha plus I beta with the eigenvalue. Here we show that this imaginary part should be vanishing. Therefore, lambda n is always real. That is because of the symmetry of the kernel. Okay. So when in the given equation, when the kernel is symmetric, in a given Fredholm equation, when the kernel is symmetric, then its eigenvalues are always real. So this is an important result. Agree. Okay. Now we consider the iterative method. What is an iterative method? The iterative method means, consider a Fredholm integral equation. Consider a Fredholm integral equation of second kind, that is y of x equals, it is f of x plus lambda integral a to b, it is k x theta y theta d theta. K x theta y theta d theta. So let y not be the initial approximation. Let y not be the initial, let y not be the initial approximation. So y1 be the first iteration. What is the first iteration? So its first iteration, the first iteration, comma y1x. y1x equals, it is f of x plus lambda integral a to b k x theta y naught theta d theta, where y naught be the initial approximation. It is y1x equals f of x plus lambda into integral a to b kx theta y naught theta d theta, where y naught theta be the or y naught be the initial approximation. What is the second iteration? The second iteration means we have y2x. What is y2x? It is y2x equals again f of x plus lambda integral a to b, it is kx theta y1 theta d theta, where y1 theta or y1 be the first iteration. So proceeding like this, what is the nth iteration? Nth iteration means it is ynx. Ynx equals, it is f of x plus lambda integral a to b k x theta y n minus 1 theta d theta. So this is the iterative method for solving a Fredholm integral equation. Okay. So, for example, come to a problem. Consider solve by iterative method. Solve by iterative method, that is y and x. Solve by iterative method. Here y and x equals 1 plus y and x equals 1 plus integral 0 to half. So integral 0 to 1. Integral 0 to 1. 1 minus 3 x theta y theta d theta. Find the solution by iterative method. Find the solution of this Fredholm integral equation by using iterative method. So it is given y and x equals 1 plus integral 0 to 1, 1 minus 3x theta y theta d theta. What is kernel here? Here kx theta is 1 minus 3x into theta. Okay. So let y not be the initial approximation. Y not be the initial approximation. So the solution of this equation. What is the solution? So the solution is, it is y and x equals, or y and x equals f of x plus, here f of x is 1 plus sigma n ranges from 1 to infinity. It is lambda power n into k power n, or k power n x theta. So it is k power n into f of x. So this is the solution of this Fredholm integral equation by iterative method. We have to find out the solution of this Fredholm integral equation by iterative method. So the solution of this given integral equation is y and x equals f of x plus sigma n ranges from 1 to infinity lambda power n k power n f of x. Okay, k power n into f of x. What is k into f of x here? Here, k into f of x. What is k? Kx theta. K into f of x means it is integral 0 to 1. It is kx theta into f of x dx. Okay, kx theta into, not f of x, it is f of theta d theta. K f of x equals integral 0 to 1. Kx theta f of theta d theta. What is f of x? It is 1. Here, f of x equals 1. Since f of x equals 1, what is f of theta? F of theta is 1. So it equals integral 0 to 1, 1 minus 3x theta into 1 d theta. Okay, so it equals 1 d theta, it is theta. When it supplies lower and upper and lower limit, it is 1 minus 3x theta square by 2. So it is 3 by 2x. 1 minus 3 by 2x. What is k square f of x? Equals integral 0 to 1. K square, it is yes, k x theta into k x theta f of theta d theta. So that equals integral 0 to 1. 1 is 1 minus 3x theta. 1 minus 3x theta into kx theta into k square f of x. What is k into k f of x? What is k f of x? It is 1 minus 3 by 2x. So it is 1 minus 3 by 2x of d theta. Okay. So it is integral 0 to 1, 1 minus, so 3x theta into 1 minus 3 by 2 theta d theta. 1 minus 3x theta into 1 minus 3 by 2 theta d theta. So it is nothing but, after calculation, it is 1 by 4. You can calculate this one, then integrate, then it is 1 by 4. Okay. What is k cube f of x? Equals integral 0 to 1. It is kx theta into k square f of x, or k square f of theta d theta. That equals again integral 0 to 1. It is 1 minus 3x theta into, what remains? It is 1 by 4 d theta. Okay. Then what you get? It is 1 by 4 into k cube. It is 1 by 4 into, then you can integrate this one. So it's, that integration is 1 by 1 minus 3 by 2x. Similarly, you can find out k power 4, k power 4 f of x, k power 5 f of x, and so on. Therefore, our solution is, what is solution? Y and x equals f of x, that is 1, plus sigma n ranges from 1 to infinity. That is, first one is when n is 1, that is lambda kf of x. What is kf of x? Lambda into 1 minus 3 by 2x plus lambda square k2f of x. That is lambda square into 1 by 4 plus k3f of x. That is lambda cube into k3f of x, k cube f of x. That is, it is 1 by 4, 1 minus 3 by 2x, k cube f of x, not a k3. It is ynx equals 1 plus lambda into 1 minus 3 by 2x plus lambda square 1 by 4 plus lambda cube by 4 into 1 minus 3 by 2x plus etc. Okay, so which is nothing but, so it is that equals 1 minus 3 by 2x is commonly there. So it is nothing but 1 plus lambda square by 4 plus it is lambda power, next term is lambda power 4 by 16. Okay, and so on. So you can find out, then you can sum in these terms, then finally it is ynx equals some 4 plus 4 lambda into and so on. Okay, so this is our iterative method. So first you find out y0 to be the initial approximation, y1, y2, y3 etc. be the first, second, third approximations or third iterations are respectively. Then in order to find the solution of a Fredholm integral equation by using this iterative method, the solution is given by ynx equals f of x plus sigma n ranges from 1 to infinity lambda power n k power n f of x, where k f of x is integral a to b kx theta f of theta d theta. K square f of x is integral integral a to b kx theta k f of theta d theta. That is the term obtained in previous calculations. Then you can proceed like this. Then finally apply all of these values in here. Then ynx equals f of x plus sigma n ranges from 1 to infinity lambda power n k n f of x. That is our required solution. Okay.